This video goes through the Bayesian nets and the causal and predictive market views and stress testing functionality. So first we'll go through the theory, and then afterwards we have many different Python examples where you can see how this is actually implemented in practice. So the idea for using Bayesian nets for causal and predictive market views and stress testing is something that is introduced in this portfolio management under stress book. But compared to this book, the way that we implement it here, it's for fully general Monte Carlo simulations, and it's for fully general discrete Bayesian networks. So basically we improve on some of the fundamental issues with this suggestion. So this is what you will see, that there's no reliance on covariance matrices, no reliance on normal distributions, no reliance on just Boolean networks. We will focus on fully discrete variables. So basically this Bayesian network, it's a directed acyclical graph, which, this is the terminology from the graph theory perspective. But the way that you can think about it is it's an overview of several variables and their causal relationships. So basically this conditional dependency in a usual Bayesian network does not always imply causality, but this is the usual assumption that people they make. And that's also important for us to stress, that whenever we assume that something is causal, well, in financial economics it's almost always an assumption. Of course, we know that, for example, interest rates affect bond prices, but in many other cases it's actually us that come up with the causal hypothesis, and this is what this framework will allow us to work with and actually impose some causal relationships that we think that are there but haven't been present in the historical data. So this is the quantimental nature of this approach. Alright, so we will see how we can use just these Bayesian nets just for an interesting macroeconomic analysis on its own, but they become very interesting when you combine it with entropy pooling, so that you can translate your, let's say, macro views and hypotheses into the P&L in your portfolios. Alright. So this is where we look here, where there's a description of how we integrate entropy pooling into Bayesian networks. And this is this causal and predictive stress testing. So basically you can think about the Bayesian network as a method for generating joint causal views and then their probabilities. And then we just take these views and we implement them using entropy pooling. So we get several different posterior probability vectors, and then finally we weigh them by the joint scenario probabilities, and then we have one predictive posterior distribution which we can analyze however we want. So basically in the examples that we will see is that we take some macroeconomic information, and then we define some different variables like call risk premium, break-even inflation, real rate, and then specify some views there. So that's the essence of it. So while the theory and the mathematics and actually also the implementation, it's very, very complex, but then conceptually it's quite straightforward. And my experience is actually that once people start to use these things and they see what the input is and what the output is, it's very, very intuitive for them, but we just go beyond the intuition, beyond the qualitative analysis, and actually have some estimates of what will happen in different scenarios. So this is where the technology is powerful. The mathematics though can be quite complicated, and it's something that you can read the full documentation of it and how it integrates into the next generation investment framework. It's of course given the portfolio construction risk management book. So basically if you go to this post on Substack and you scroll down to the bottom, you can download the latest version of the book, and then here in chapter 5 everything is presented in a coherent way. So this is what I suggest that you do. This is what will give you the most complete presentation of the theory. But you can of course also just read this article on SSRN, where basically it's just the framework that is presented. It's a bit more to the point in this case, but all the details are still there. So just to give you some idea of what actually happens with the mathematics in this framework, we can imagine that we have a very, very simple Bayesian net where we just have two nodes at the end, which is inflation and growth. And here you can see that there is this example that it's discrete Bayesian networks or discrete variables, and they can have different number of states. So inflation, for this example, we say it can be low or high, and for economic growth, it can be low, trend, or high. So basically, then we assign some probabilities to each of these states. And then in this case that we have formulated this very simple Bayesian network, we know that these variables are conditionally independent. It's something that you can read more about in the portfolio construction risk management book. So what that means is that when we want to compute the joint probabilities of these realizations, well, we can just take this probability of low inflation, multiply by low growth, trend growth, and high growth. So this is what we show here, where we define some index, which is this Cartesian product of inflation and growth states, and then we compute their probabilities. So just to make things very, very simple, in this case, I provide it in a uniform way. But the idea is that then each of these scenarios, you can formulate it as an entropy pooling view. So this is what we show in this case. So basically then we will have 6 posterior probability vectors, and then we must multiply the joint probabilities of each of them. So this is what we do here in the end, and then we get the final posterior probability vector. So the thing is, of course, this is just unconditionally when we specify this Bayesian network structure. But once we have this, we can also go in and specify what if we condition on the growth being positive. Then we can compute a posterior probability vector for that scenario, or we condition on inflation being high and growth being high, for instance. So that's how we will use it in the examples afterwards. And this is what you can see here. So basically, we use this prior with the macro variables from before. This is something that we will see in the Python examples. And we have some low risk portfolio where we show the portfolio P&L distribution just in the prior case. So this is the blue line, and then we implement a positive growth surprise. So basically this is where we say that the growth is high compared to the trend, and then we can see that it shifts our portfolio's P&L distribution to the right, which is probably as expected. Then we can also implement some scenario if there is stagflation and a rate hike. So this is the scenario where growth is low, inflation is high, and central banks still decide to increase interest rates. So this will make our portfolio's distribution shift to the left. So of course, as you can see in this case, the results that we get are quite intuitive, but we can actually analyze them much more deep now that we have these quantitative estimates for the portfolio P&L distribution, and we can also analyze, for instance, tail risk hedging much more carefully in this case. So this is what you will see here, is that it's in this stagflation and rate hike scenario, it's interesting to analyze how equities and government bonds they behave in this case individually, and try to identify scenarios where we lose at the same time, and then see if we can build tail risk mitigating strategies for these scenarios specifically that work in this case if we are afraid about this scenario. So this stagflation rate hike, this is usually what most investment managers are afraid of. So it's of course interesting to have an estimate of how you can do these things. So basically, these Bayesian nets, so far we have analyzed it as originally introduced in the first book that worked with Bayesian nets. But actually, the way that we implement it, you can work with it in a much more sophisticated way, because you can have fully general entropy pooling views for these leaf nodes. And here there's one example where you could analyze a scenario with a risk on and a risk off scenario and a change in the equity and bond correlation. Because many investors, they have this idea that if you are in a risk off scenario, well, then probably there will be some safe haven properties for government bonds, so that you will get a higher return and it will have a negative correlation with equities. While if you're on a risk on scenario, maybe if it's driven by inflation, well, then you have less diversification, and maybe there's a fall in bond prices in this case. So basically this is what we illustrate. So you can see you have this base case, that's the blue curve, and then you have these different risk on and risk off scenarios, and you can see how the correlation changes. In the risk off scenario it's negative, while the return on the bonds is positive and the return on equity is negative. And then here in the risk on scenario we implement something where the correlation is positive, the return is negative for these government bonds. The thing is that you can also work with these different matrices that have become popular. So for instance, if you have scenarios with high inflation or high growth or low inflation, or some combination of them, and then you can see how your portfolio distributions react in this case. And actually you can weigh your posterior probability vectors such that they represent the probability you think that to each of these different combinations, and then you can perform a final optimization of your portfolio in this case. So this is also something that I see sophisticated use of this framework in this way. The point here is just that it's very, very flexible, so it's mainly our imagination that is the limiting factor. So this is also the final comments that I have here is that these posterior probabilities that come out from this causal and predictive market views and stress testing framework, we can use it in all parts of the investment analysis module. So basically optimization, risk decomposition, all of these things, and plotting. So it's basically just a different way of computing a posterior probability vector compared to just the raw entropy pooling application. And you can think of the Bayesian net as something that helps you generate joint causal and predictive views in a logically consistent way. So that's it. It's a structured approach that you have to these things compared to just coming up with some view. Okay. And that's the final comment, that I encourage people to really be creative in how they use these things and not be limited by the applications that we show in the examples, because in the examples we just illustrate the interface of how you work with these technologies. That's it. So this is the next step now, to go through different Python examples, and this is what we will do here. So this is examples for the investment analysis module. So you go to examples and then investment analysis, you have it there, and then we'll go through example 4, 5, and 6.